now we have derived the scalar part of the transport equation and also the vector part of our transport equation. So next we can insert the vector part into the scalar part of the transport equation. So that will be like 1 over v times derivative of phi over t minus the gradient of d over v gradient of phi plus mu a times phi equals to S0. So next we multiply by v to each term. So that will be derivative of phi over t minus the gradient of d times gradient of phi plus v times mu a times phi equals to v times S0. So next we make our fourth assumption, assumption 4, that is our tissue is actually homogeneous. That means D, the diffusion coefficient, is actually the same everywhere in our tissue. With that assumption, we can take D outside of the gradient sign. So that will make our equation looks like phi over dt minus d times double gradient of phi plus v times mu a times phi equals to v times S0. So here we have derived our diffusion equation. So in this diffusion equation, we can see that the change of photon fluence is actually affected by 3 parts. The first part is the divergence due to diffusion. This term describes the diffusion phenomenon, so we can think of it as we put a drop of ink into the water, and without any outside force, the ink will diffuse inside of the water. So if we so the photon kind of also follow that phenomenon. So if we put a bunch of photon in the tissue, and then it will diffuse inside of the tissue like this. So this term describes that phenomenon. So that's the first driving factor of the changing of the photon fluence phi. So the second term describes the absorption of the photons. So unlike ink, a drop of ink inside of the water, the photon can be absorbed by the tissue, so that this term describes that phenomenon. And then the third one is the photon source, the light source, is continuing, is a driving factor of the changing rate of the photon fluence. So now we have described the details how to derive this diffusion equation from our transport equation, and the 4 very important assumptions. But this diffusion itself is, as I said, each part of it is also very understandable. So in a lot of scientific literatures, people can just start from this diffusion equation. They don't have to derive all the way from the transport equation to this diffusion equation. So if we see something like this diffusion equation, we can also very quickly understand what it's describing.